Hello everyone and welcome to Physimania. In today's video we're going to be learning about the motion along a straight line. If you want to go to a specific part of this video, please go to the box description where you will have the times of the video. So without further ado, let's start. To study the motion along a straight line, we're going to start by investigating what are the concepts of displacement, average velocity, and average acceleration. We're going to start with displacement and we're going to pick an example of a car that is racing in a straight track, in a straight line, in order to understand what displacement is. So let's say that after the clock starts ticking, after 1 second, this car has an initial position P1 equals to 4 meters. And then after 4 seconds after the clock starts ticking, this car has a final position P2 equals to 100 meters. Now these positions are all the initial position and the final position are all with respect to the origin, as we can see here. And then what we can say about the displacement is that this is a vector that points from the point P1 to the point P2, meaning this vector, this displacement vector, is a vector that indicates the direction in which the initial position goes to the final position, meaning it's a vector that points in the direction from the initial position to the final position. Then mathematically, we can describe this vector as being the difference between the final position and the initial position, and because this is a vector, we need the unit vector indicating the direction. In this case, because this is a straight line and we choose the x-axis as being the direction of motion, then our unit vector is going to be the x-axis. Therefore, with the numbers that we have in our example, we have that this is 100 meters minus 4 meters in the x direction. Therefore, our vector or displacement vector is going to be 96 meters in the x direction. Now that we know what the displacement is, we're going to start studying the average velocity. Well, so what is the average velocity? The average velocity is the vector whose magnitude is equal to the displacement divided by the time that it took the object to move from one position to the other. Meaning, mathematically we can say that this average velocity is the magnitude of this vector, right, which is equal to the magnitude of the vector of displacement divided by the difference in time, which is equal to the final position minus the initial position divided by the final time minus the initial time. So in our example from the car, we have that this is equal to 100 meters, the final position is equal to 100 meters, and the initial position is equal to 4 meters. Therefore, we have 100 meters minus 4 meters. And then the final time was 4 seconds, and the initial time was 1 second. Therefore, we have 4 seconds minus 1 second. And as we can see, this gives us 96 meters divided by 3 seconds, which gives us 32 meters per second. Therefore, our average velocity has a magnitude equals to 32 meters per second. And how do we describe this as a vector? Then our vector will be equals to this magnitude times the direction of motion. In this case, the direction of motion is in the x-axis. Therefore, we can say that the average velocity vector is going to be equals to 32 meters per second in the x direction. And this is our average velocity. Now we're going to see what is the average acceleration. We define the average acceleration as the vector who indicates the difference in velocity over a period of time. What this means is that we have mathematically the difference in velocity divided by the difference in time to go from one velocity to the other. This means that we have an initial velocity and we accelerate or we increase our velocity up to a final velocity in a period of time, and this period of time is just, for example, from 1 second to 3 seconds, or from 2 seconds to 4 seconds, something like this. Therefore we have this velocity final minus this velocity initial divided by the final time minus the initial time. And then, because this is a vector, we also need to indicate the direction of the vector. How do we do that? With a unit vector. In this case, I'm just using a unit vector n, which serves to indicate any direction. For example, if we're moving in the x direction, we will substitute this n unit vector by a unit vector x, or the x coordinate unit vector. If we're moving in the y direction, then we will substitute it by the y hat unit vector. But because what we're studying now is only motion along a straight line, we're only simply going to assume that we're always moving in the same direction, and then we can just simply say that the average acceleration is equal to the magnitude of this vector, and the magnitude of this vector is simply the velocity final minus velocity initial divided by the final time minus the initial time, which is equal to simply the difference in velocity divided by the difference in time. And this will be our average acceleration. Now, if we're given a graph of position versus time, as we can see here, where position is in the y-axis and time is given in the x-axis, how can we find the average velocity of an object? Well, let's say that in this graph, right, the motion along a straight line of the object is given by the blue line. Now, and as we can see here in the blue line, we have 2 points, P1 and P2, and P1 is the initial position, which corresponds to 50 meters at 2 seconds, and the final position P2 corresponds to 150 meters at 4 seconds. As we know, finding the average velocity is given by the division of the displacement divided by the difference in time, right? So as we can see here, taking this average velocity is like taking the slope of a line that passes through these 2 points. And as we can see here, the displacement is going to be simply 150 meters minus 50 meters, which is going to be equals to 100 meters, divided by the difference in time. And this difference in time is simply 4 meters minus 2 seconds, and this is going to give us 2 seconds. Therefore, our average velocity is 100 meters divided by 2 seconds, which is equal to 50 meters per second. Now, as we can see on the second graph on the right, the motion along a straight line for this object is this blue curve again, and again we have 2 points, P1 and P2, and the initial position of this object corresponds to 50 meters again in 1 second, corresponding to 1 second, and then the second position, right, corresponds to about 80 meters, and it corresponds to 2 seconds. Therefore, our average velocity, as we can see again, is just the displacement divided by the difference in time, which is equal to the displacement being 80 minus 50, which is equal to 30 meters, and then the difference in time, which is 2 seconds minus 1 second, which is equal to 1 second. Therefore, we have 30 meters divided by 1 second, which is equal to 30 meters per second. And like this, we can find any average velocity from a graph in which we have position and time. Likewise, we can also find the average acceleration from a graph in which we have the velocity in the y-axis and we have the time in the x-axis. So, for example, to find the average acceleration, we know that this is given by the formula equals to the difference in velocity divided by the difference in time. So, for example, in this first line, we see that the initial velocity at 1 second is equal to 1 meters per second, and then the final velocity is equal to 3 meters per second in 3 seconds. Therefore, taking this difference of velocity, this is 3 minus 1 meters per second give us 2 meters per second, and the difference in time is 3 seconds minus 1 second is equal to 2 seconds, which give us equals an average acceleration equals to 1 meter per second squared. Now, the second line is simply a straight line, it's a flat line. So this means that the velocity has not changed in this period of time. So this means that we have a 3 meters per second for 1 second, right? So the difference in velocity is equal to 0. So our average acceleration here is simply going to be 0. But now on the third line, as we can see here, we have a difference in velocity that goes from 3 meters per second to 2 meters per second. And this goes from 4 seconds to 5 seconds. Therefore, our difference in velocity is going to be the final velocity 2 meters per second minus 3 meters per second divided by 5 seconds with minus 4 seconds. And this gives us an average acceleration equals to negative 1 meter per second. And what this negative means only is that this object is decreasing its velocity, meaning its acceleration is negative. And with this we can find again any average acceleration given a graph like this in which we have velocity and time. So with this we have finished today's video. I hope you have liked it a lot and you have learned a lot too. Thank you for watching me, and see you next week.